All right, welcome back to our first target in Unit 7. In the previous target, guys, we talked about angles, and we really changed the landscape in terms of what an angle could be, how we measured an angle, in terms of rotating around a fixed point, and we talked about some different vocabulary words right over here, initial side, terminal side, positive, negative angle measures that, you never had a negative angle measure in geometry, and coterminal angles. What we're going to introduce here in the second video is a different unit of measurement. Now, what we've got to understand here, guys, is that what we're doing is just changing the measurement. This is the same thing as if you measure something in inches and then you change it, you convert it to centimeters, right? We're changing the unit. We're changing the kind of the value of a single unit of measurement, but we're really still doing the same thing. Whether you weigh yourself in pounds or whether you weigh yourself in kilograms, like they do in Europe and, well, most of the rest of the world, actually, it doesn't really matter. The number's going to change. It's going to look like a different number, but what you're doing is exactly the same. So let's dive right in here to radians, because radians and degrees are going to be like inches and centimeters, like pounds and kilograms. They're measurements, they're units for the same exact real life thing, but they're going to have a different foundation on how they define that measurement. So a radian is a unit of measurement, of an angle based on the radius of the sides used to create that angle. All right. Now, when we worked with our angles previously, guys, we thought of these as a ray, right? An array has no end, so we really can't measure it. So what we're saying is radians come when the radius, when that initial side and the radius, guys, would essentially be our initial and terminal sides of our angles. And so what we're saying is we can measure something in radians if we put a limit and treat that initial and terminal side as a segment and not a ray. So initial and terminal side of an angle, and they would be segments, meaning they have a beginning and end, instead of a ray, which, guys, remember, that's what we did before. So if I were to actually take this circle right here and I were to draw my initial side, but have endpoints for that initial side, rather it be a ray, I now have a measurement, which is the radius, guys, and that's what radians is built upon. That's what radians is founded upon, not on degrees, not on rotations, but on the length of the radius. Right now, there's a lot of stuff we would normally go into to kind of discover things, but we're going to try and keep things as simple as possible here. The best way to understand how to think about radians is to talk about how it compares to degrees, because I think degrees is a measurement we're very familiar with. So if we can understand how radians and degrees communicate, work together, the same way we understand inches, 1 inch is 2.54 centimeters, understanding how centimeters relates to inches helps us measure things in centimeters better. We're going to understand how radians compare to degrees to help us understand radians better. And we're actually, guys, given the ability to do this with the circumference equation for a circle. And this, I think, is probably something you definitely did in geometry and probably even in 8th grade. And the key is understanding that one full circumference, one full rotation all the way around the circle is 360 degrees. So we can think about our circumference equation when we're comparing degrees and radians as 360 degrees, that's what C is, is equal to 2 pi r. Now, here's the thing. What we need to understand is that the units are the degrees. That's the unit of measurement here, and the unit of measurement here is the radius. And don't think about this as much as a formula, but as a comparison tool. So what we see then, if 360 degrees is equal to 2 pi radians, well, that means that 360 and 2 pi are going to be equal. That 360 and 2 pi are equivalent measurements when it comes to our radians and our degrees. One full rotation around the circle in degrees we say is 360. One full rotation in 2 pi is in radians is 2 pi. And this is going to be important, guys. Pi is always going to be part of the description of a radian if we're talking about an exact measurement. So we've got to get used to using the number pi as part of whenever you're describing radians, you're going to be saying something pi, right? And both of these are equal. They are both one full rotation. Okay, so let's talk about how that relates to each other. So if we know that 360 degrees is equivalent to 2 pi, well, what would 180 degrees be? Well, 180 is half of 360, so 180 would be, sorry, let me start that over. 180 degrees is half of 360 degrees. So the radians here would also have to be half of 2 pi, which would give me pi, right? Essentially, it's a proportion to figure out the relationship between degrees and radians, right? If 360 degrees to 180 degrees has to be the same as 2 pi to what? Well, we just said it's pi. And we can do that again with 90. Oops, I'm sorry. I wrote that in the wrong place, didn't I? Probably looking at that, you're telling the video, Mr. Dahl, you put it in the wrong place, but I couldn't hear you because it's a video. Same thing with 90 here. 90, 180, and 90. 90 is half of 180. So the radians here have to be half of pi, or 2 pi. All right. And 270, right, is halfway between 1 pi and 2 pi. So what fraction is halfway between 1 pi and 2 pi? And that's 1/2, or 3 pi over 2. 3 halves pi. Guys, we could fill in the rest of these. Let's do the easy one. How many radians is 0 degrees? That's the easy one. It's also 0. We're not going to take the time, guys, to fill the rest of these in. That would have been something we did in class and activity thinking about proportions. But what we would see if we actually took these 4 examples we have and broke them down is there is a conversion constant for both directions, going from degrees to radians and radians to degrees. We already talked about one of those for length, centimeters and inches. 1 inch is always equal to 2.54 centimeters, and 2.54 centimeters is always equal to 1 inch. And using that conversion relationship, you can always change between measuring something in inches and centimeters. We can do the same things with radians and degrees. All right, and that conversion ratio is going to involve pi and 180. Now, the actual value we're going to use is going to, the way we use that relationship is going to change depending on which direction we're going. All right, if we are starting with an angle in degrees and we want to convert it to radians, what we are going to have to do is we're going to have to multiply that by pi over 180. All right, multiplying, and again, we're not going to go into super detail, guys, about how we come up with that, but our conversion ratio going from degrees to radians is going to be pi to 180, and what we'll come out with is an angle measure in radians. We'll start with degrees, multiply, this is our conversion ratio, we get radians. All right, going the opposite direction is literally just the opposite ratio. So if I have an angle measure in radians, I'm going to multiply that by 180 over pi to convert that into an angle measure in degrees. All right, so really just kind of simply here, if we're going from degrees to radians, we are going to multiply by 180 over pi. If you want to end in radians, you need pi, so pi is on top. If we're going from radians to degrees, we want to get rid of pi in our measurement. Think about it, so pi goes on the bottom, and those are our conversion ratios. All right, so let's take a look here, and let's practice doing that. So I start with degrees here. I start with 60 degrees. So I know my conversion ratio for degrees is multiplying by 180 over pi. So this would give me 60 pi over 180. Now, what is the age-old rule with fractions? Fractions need to always be written in their simplest form or most reduced form. Now, the pi we just leave. We can't really do anything about the pi, but can we simplify 60 over 180? And the answer is yes, right? We can divide 60 by 60, and we can divide 180 by 60, and what we'll end up with is 1 pi over 3. So 60 degrees is the equivalent. I'm sorry. Let me label that there. And the abbreviation for radians, guys, is rads. So rad. So 60 degrees is the equivalent of pi over 3 rads. Now, I will tell you, you're going to like degrees better than radians because radians are going to have to be used in a fraction form, and you're probably not going to like that very much. But it is what it is. That's the math. I can't do anything to change that for you. Let's do it. Let's do an example. Let's go with a negative one here. Oh, that's actually, you should probably be able to just by hopefully kind of just by observation figure that one out. So let's talk about number 3 here. So if we have 11 pi over 4 radians, how do we convert that into degrees? Well, we're going to multiply by 180 over pi. Now, one of the reasons we do this, you can see, is that pi in the numerator is being multiplied by something with pi in the denominator, so they cancel. So what we really just have to do is multiply 11 by 180, put it over 4, and simplify our fraction. So if we do that, that is going to be 1,980 over 4. Now, guys, use your calculator. I'm fine with you using your calculator here. I'm not asking you to kill yourselves trying to simplify fractions. But if we do this, we're going to get what? 380. I'm trying to use my head. So we're going to have an angle measure of 438. It's going to go 90, right? And that's going to give me 36 and 5, I believe. So 495. I did just do that in my head. So hopefully that gave you time to get your calculator and double check my work, but 495 degrees. So again, what we see here is that 11 pi over 4 radians is the equivalent of 495 degrees. All right. Now, here's the deal. If you really, really, really hate working in radians, most of the time, we might ask you to actually work in radians, but most of the time, you can always convert to degrees, do the work in degrees, and if you have to give an angle measure in radians, which, guys, there are going to be times we're going to ask you and tell you that your answer has to be in radians, then you can just convert back. You can use these two conversion ratios to get into degrees, work in degrees, and convert back to radians. So let's do an example here. All right. So we know right away, going back standard position, right? We know we need an angle measure here. But you're probably asking yourselves, what in the world? Where in the world is 5 pi over 4 radians? I don't know where that is. That doesn't make any sense to me. So let's do the work to take 5 pi over 4 and convert that into degrees. All right. So 5 pi over 4, the pi's are going to cancel. 5 times 180 is going to be 900, right, over 4. And 900 divided by 4 gives me 225 degrees. So an angle measure of 5 pi over 4 radians is equivalent to 225 degrees. So let's go 225 degrees, which puts me somewhere in my third quadrant. All right. And then we need just to label this as 5 pi over 4 radians. All right, guys, one thing you can do that would help with radians is to think about the quadrantal angles that we talked about here in terms of radians and in practice labeling them. Right. So this is 0 radians. This is pi over 2. This is pi, right? This is 3 pi over 2, and then fully around would be 2 pi. So if you're good with fractions, this can save you the effort of having to convert to degrees, because you can say, okay, 5 pi over 4 is a little bit bigger than 1 pi right here, but it's not as big as 3 pi over 2, so it has to fall somewhere between. Now, if you hate fractions and you have taken a vow to never do anything in fractions, if at all possible, then convert to degrees, work in degrees, but just make sure you label your answer like I did here in radians. All right. You can do the same thing with negative 7 pi over 6. Just make sure that you're rotating clockwise to get a negative angle measure there. Now, the only other thing, guys, we're going to ask you to do here is to find positive and negative coterminal angles in radians. Now, we talked about this again on the other page. Previously, guys, when it was degrees, we added and subtracted 360. Well, now we're going to be doing the same thing, but we're just going to be adding and subtracting 2 pi. Now, if you want to do the same thing we talked about, where you just convert to degrees, do the work in degrees, and get back to radians, you can. But I'm going to show you how to do this with fractions and refresh our memory on adding and subtracting fractions. So I want a positive. I'm going to save a little more space here because we're going to need a little more space with these here. Coterminal angle measure and a negative one. Let me put those more in the middle. There you go, positive and negative. Right, so both of these are going to start with pi over 6. All right, both of these are going to start with pi over 6. Now here I'm looking for a positive one, so I'm going to add 2 pi. Here I'm going to subtract 2 pi. Now the key is, though, guys, we can't add these fractions because they don't have a common denominator. Remember, the denominator is 1. Our denominator for 2 pi is 1. So this has a denominator of 6. This has a denominator of 1. We can't add them. We need to convert 2 pi over 1 to have a common denominator of 6. So if I do that, well, to change 1 to 6, I have to multiply by 6. So I have to multiply 2 pi by 6, and I get 12 pi over 6. So you can see adding 2 pi to pi over 6 is the same thing as adding 12 pi over 6 to pi over 6. 1 pi plus 12 pi gives me 13 pi over 6. And that would be in terms of radians. And let me be diligent about writing my units of measurement, right? Got to make sure we do that. That would be 13 pi over 6 radians. Now, the nice thing is, once you convert 2 pi for the positive, it's the same ratio here. So now this is 1 minus 12. So I get negative 11 pi over 6 radians. All right, guys, this is all just simplification, just arithmetic, just practicing with this. I guess the 10 is really nice because adding and subtracting 2 pi to 3 pi is easy. Let's do one more where we have to actually work with a denominator where we have to change that denominator. So pi, pi. Addition and subtraction here. So I'm going to start with negative 7 pi over 9, and I'm going to add 2 pi, and I'm going to start with negative 7/9 over pi, and I'm going to subtract 2 pi. But we need a common denominator with a denominator of 9. So this is going to be negative 7 pi over 9 plus 18 pi over 9. There's my common denominator. 18 over 9 is 2. And when I do that, negative 7 plus 18 is 11 pi over 9. And we are, get my unit in there, radians, and we're good. Here, negative 7 pi over 9 minus 18 pi over 9. Negative 7 minus 18 is negative 25 pi over 9. So I get negative 25 pi over 9 radians. All right, I know radians is a mouthful, guys, and if we had the time in class, we would talk about why we don't just use degrees, because that's a very valid question. That is a very fair question. Degrees are so much easier. We don't have to deal with fractions. There's no pi there. Why do we even care about radians? There is a good answer. I would encourage you to Google that. There are plenty of videos out there that describe that. We just don't have time or kind of the bandwidth right now in our e-learning time to talk about the why, but we need to make sure we do have the what and the how down. All right, so guys, that's the end. Anything I didn't do, please check the notes for any answers to problems I didn't finish. And this is going to be a foundational. These notes, guys, have kind of all of the new foundational aspects that we're going to carry forward the rest of the unit. So work on this, ask questions, and I'll see you when we get to Unit 7, Target 1B.